Good afternoon, and welcome to the main stage. We've got a fantastic block of speakers coming up. But first off, I'd like to welcome my friend Shannon Deminick to the stage. He's going to be talking to us today about Examine. So a huge round of applause, please.
Cheers. Super Skull. Okay, here we go. So my name is Shannon Deminick. I used to work at Umbraco for the last 10 years, and recently I've transitioned to Microsoft, but I'm still very much in this community, and we're going to talk a little bit about Umbraco, Examine, Lucene, and how that works on Azure. We have only got 25 minutes, so I have to apologize because originally this was going to be a deep dive, but now it's more about the ins and outs of all of these things put together. So here we go. Let's start off with what is Lucene.net. So Lucene.net is a fully featured search engine library that by default uses a file-based storage system. This is very important to remember as we go through these slides. It's a Java port of the original Apache Lucene project, almost a line-by-line port from Java to C#. It underpins many of the major search as a service products, which we'll talk about in a little bit here. And it's an open source project that would love all the help it can get. To be honest, this project is only run by 3 people. Myself, and I just do all the documentation, website building and everything. I actually don't do much of the coding, but there's only one other person that goes by the name of Night Owl. His name is Shad. And he has been working on this project for years. Just one guy. And I think there's like 450,000 lines of code in Lucene. Like, it's enormous, right? So you can imagine this is not a small undertaking. It's absolutely huge. He's been working on Lucene 4.8 since 2014. You can imagine, like, that's a crazy amount of work. I think he said he's put over 5,000 hours into this project, right? It's massive. So if you go to the Lucene.net site or on GitHub, and if you want to help out, there's a ton of things that you can help out with. And it's not hard. It's just a Lucene port. Like, it's a Java port. You're not having to write code. You're just having to port things over and test it. The latest stable version is 4.8 beta 0016. There's been many betas out over the past, I don't know, 5-6 years. And this is what we're running on. This is what Umbraco 9 and 10 are running on, is on a beta. When is this going to be released? Like, what's the RTM? Nobody knows. Nobody knows. This is because it needs a bit of help. So any help that it can get would be great. But I guess Shad thinks that maybe by the end of this year could be a thing. So this is what Lucene is. And it's also worth noting that the Java Lucene version is actually on, I think, version 9.2. Right? So think about that. That's a lot of work. Without all this work, there is actually no possible way that we would have search in .NET today. So give it up for Shad. He's an awesome guy. So what is Examine? Examine is an API search and indexing abstraction layer, right? It's just an interface. But beneath the surface, it has a default implementation that is based on Lucene.net. But at the top level, it's just an interface. And its latest version is 3, which I just released, I think, a week ago. And this is to do with Umbraco 10 release, which is launched today, which is awesome. Nice. What does version 3 bring? Nothing. Version 3 just brings an upgrade from beta 0015 to beta 0016 of Lucene. There is one breaking change in it, but it probably won't affect too many of you guys. And there's documentation on that breaking change on GitHub. But what does this searching and indexing abstraction include? So it's hard to make an abstraction over searching and indexing because any implementation might have a lot of different features. So this is a generic features over searching and indexing abstraction. So we've got ranked searching, you can sort by score, simple search, which means you just search by text field, fielded search, you can search on fields. Then we've got all the fun things like wildcard range, proximity, all those fun things. It comes out of the box with a Fluent API for searching. You can customize your indexes. We've got events built in, so you can customize your index as things are being written. And then field types are like numerics, date, times, integers, all those things. But what it doesn't include are all the other fancy features of the underlying possible implementations. So facets, which probably a lot of you guys might use, spatial search, highlighting, suggesting, joins, group, spell checking, there's a lot more. Like, if you wanted to implement searching and indexing on top of an actual service, it might include a lot of other search services that you can't just abstract. So how do you actually do those things with Examine? I was going to show a ton of code today, but I can't, so I don't have time. But we'll just go through this. So let's say we wanted to do Lucene specific things like facets, grouping, joins, whatever. The way that you do that is you have to cast it to the implementation. So you're casting the abstraction to the implementation. So we've got our searcher there, which would actually be an I searcher. We're going to cast it to the Lucene searcher, and this is now very Lucene specific stuff. So we get a search context. We've got to wrap this in a using clause, because if you don't, you're going to get memory leaks. But once you do that, then you get an actual Lucene index searcher reference. This is now in the Lucene APIs. And with that, you can do whatever you want. You just have to know the Lucene APIs. But as I said, there's 450,000 lines of code. There's a lot of API stuff that you might need to know there. But this is how you would do it. And then if you did search using the Lucene APIs, you get Lucene search results back, not Examine. And you're going to have to deal with that on your own. So let's jump ahead and talk about how Lucene, Examine, Umbraco all works with how it's stored. So in traditional hosting, remember we talked about file-based storage. It used to be okay in traditional hosting. We used to have a server with a local hard drive. It was super easy back in the day, and it's fast. Lucene is okay with that. But let's jump ahead to how we host things today in Azure or cloud. And file-based storage isn't like the greatest way to store things in Azure or probably on any cloud provider. So how does this work? So this is like a diagram of how Azure stores things. So we've got our server, and we've got a temp drive. This is our local fast drive, which is synonymous to the C drive that we saw before. But all of your files are actually hosted on a network drive, so let's call it home. This is actually a network drive, which is slow. And Lucene does not like to work with this. It just won't. You're going to get delays, you're going to get file locks, you're going to get all sorts of problems. So we need to work around this. And this is how, if you guys are hosting on Azure, this is how all of these things actually work. So temp is in fact temporary. It's not durable, and when your site's moved, because Azure is going to move your site between different workers all the time, or if you scale out, you're going to get a new worker that comes online, temp is going to be empty. And when it's empty, that means when your site comes online, your indexes are going to get rebuilt for that worker, which comes with a little bit of overhead, right? So this is more of the internal workings of how this is done. So this is all shipped with Umbraco, and Umbraco customizes this. So if you've ever done Azure-based hosting or anything, you might notice some of these names. Hopefully that's showing up on the screen. Yeah. We have something called an iDirectory factory, which is responsible for creating the Lucene directory itself. By default, it just uses file system directory factory, and that means your indexes are going to be stored exactly where your website is. If you launch this using the default on Azure, that means it's going to be stored on the home drive over the network share. and you're going to run into problems. So on the documentation on our Umbraco on how to host on Azure, the default that we specify is to use the synced file system directory factory. What this actually does is it means that Lucene's going to be hosted on the temp or local fast drive, and it's always going to read from there. But when your site starts up, it actually replicates from your network drive to the local drive. Whenever you do writes, which means your content editors are saving or publishing content, it's going to write to the index. It's going to write to that local fast drive, and then it's going to replicate it back to the network drive. This all happens behind the scenes. This all happens now. Whether you know it or not, this is how Umbraco with Examine and Lucene actually works behind the scenes. And then we've got another implementation called temp environment file system directory factory. This means that that worker is going to run solely on that temp file system drive. It's not going to talk to the network drive at all, which means if you implement or you configure everything to use that, when your server comes online or offline, it's always going to rebuild indexes on every start. There's a bit of challenges with all this. So what happens if replication fails either way? Right? If replication fails from your network drive to the local drive, your indexes are going to be corrupt because the files aren't going to be there. Lucene's going to fail. And behind the scenes, I think this started with Umbraco 8 or 9, your site will still work, but behind the scenes, you'll probably get lots of error logs. Your search won't work. All sorts of things will start crashing. But you only know about this through logs. But what happens if it fails upstream? So your content editors publish, and you try to write to the network drive, and that fails. Now suddenly your network master index is corrupt. We'll talk about load balancing in a sec, but what that actually means is that all of your other replica instances could have corrupt indexes when they come online. Replication can be slow as well. So let's say we've got 100,000 content nodes or media nodes. Your index is going to be huge. And it's going to replicate down every time that server comes online. That has a bit of overhead as well. As we mentioned before, when temp is empty, your indexes are going to rebuild. And there's something important to know about that overhead. It's not about the index rebuilding. The overhead there is actually pretty small. The overhead for index rebuilding is actually the overhead with SQL queries, right? It's querying the database directly to rebuild that index locally. So you can imagine if you scale out to say, I'm going to add 10 more servers, and they all come online at once, and your temp drive's empty, that means all of them get to rebuild the index at one time, which means all of them are sending really intensive SQL queries to your SQL server to rebuild all their local indexes. So your SQL server is going to get the brunt of the performance hit right there. Some of you may have had file lock issues with Lucene before. This may have happened in Umbraco 7 and 8, and on startup, it means your site didn't even start at all. Now, your site will still start, but nothing will actually work. File locks can happen if your Azure instance just crashes, or something else crashes, or it's in the middle of a write. Who knows? It's a hard one to debug. And the other fact is that working with the local temp drive in Azure is a bit of a workaround. I've actually seen no documentation from any Microsoft anything that says, if you wanted to work with the local temp drive, you could. We've just figured out that that is possible, and it works, but it is a bit of a workaround. So let's talk about load balancing here, because this gets a bit more complicated. It's important to know that Lucene indexes cannot be shared at all between processes. So only one process can have one index. So this is kind of how the setup works with load balancing in Azure. We've got our primary server and our replica. And I think the terminology's changed recently, but we'll stick with this for now. Your primary one is the one where your content editors log into and they edit content. And there's a reason why this needs to happen, is because a Lucene index can only be shared with one process. So what happens is the primary server, your content editors log in, they save content, it writes to that one primary index, and as we said, writes to the local fast drive, then it syncs to the network storage drive. And then what happens behind the scenes is we write to the database as well, and all your replicas read from the database to read instructions, and those instructions then instruct those replicas to then update their local index. If we scale out and we add another replica instance, the temp drive is going to be empty and it's going to rebuild its own index, right? So every single server, when you're load balancing, has its own local index. There's some challenges with that too. Namely, one server can only write. So this is predominantly why we have to have this primary server situation where you can't load balance your editor server. And indexes can get out of sync. So you can imagine if you've got 20 servers all scaled out, there's no way to know if all those indexes are perfectly in sync. As I said before, there's overhead for rebuilding, especially if you scaled out like 10 at a time. Your SQL server is going to feel the brunt of it. And then we've got different configurations for each server that you need to manage. So your primary server is going to use that one implementation that we described before, and your replicas are going to have to use the other one. So there's a bit of overhead for maintenance for you guys to do this. And the last three, I put asterisks beside because we can actually solve all of these problems. There's no way to rebuild an index on a specific server. There's no way to rebuild indexes on all the servers. And there's no way to report out-of-sync indexes on any servers today. But this has been in my backlog for about 5 years, and I've just never got around to doing it. But those three things are, in fact, possible, and potentially 1 year we can make that happen. So are there solutions to this problem? There sure are. But a lot have been attempted before over the past, 10 years. Unfortunately, all of the solutions involve file replication because Lucene indexes cannot be shared between processes. So at some point, we made a blob storage provider for Lucene, but really that's the same as having a local drive and a master network drive. It doesn't matter if you've got a master drive anywhere, whether it's in blob storage or on the network share or anything, it still requires file replication upstream and downstream. And there's problems with that. So we haven't really solved all of those issues. If you scale out and a server comes online, sure, it could replicate from the master index. That's possible. But if that replication fails, well, then your indexes are broken. So this doesn't actually solve the problems. It just kind of makes it a little bit better if we try to do that. So what's the actual solution to all this? So search as a service is the actual solution to all of this. There's 3 search as a service providers that are based on Lucene. These are major providers in the industry. There's Azure Cognitive Search, there's Elasticsearch, and there's Solr. Solr is actually baked into the Lucene code base. So Lucene, the Java original port, actually has Solr baked into it. So it's its own REST API that manages search as a service. And what does this solve? So if we actually use search as a service instead of local Lucene-based files, we have one index. It doesn't mean that every server's got its own index. We've only got one. There's no file-based storage that you need to worry about. There's no file locks that you need to worry about because we're not hosting our own indexes. Index rebuilds don't need to happen because it's actually stored in its own service. And you can have multiple primaries, which means we no longer have that restriction where we have to have one primary server that does all the writes. If we did this, potentially it means that we could start load balancing the back office, which would be absolutely ideal. What's more is each of these services offer way more features than what's actually built into Lucene and what's actually built into the Examine abstraction APIs. But remember, Examine is an abstraction, and it can be implemented on any of these services, not just Lucene, because it's just an implementation detail. This is the reason why I created something called ExamineX. You can go check it out on examinex.online. And currently, it has an implementation of Azure Cognitive Search. I'm 50% the way through creating a provider for Elasticsearch, and then after that, I'll create one for Solr Search as well. And then it gives everyone the opportunity to use whatever provider they want under the hood. It literally is a drop-in replacement. So if you install ExaminX on top of your Umbraco sites, it will just change what the underlying provider is. So instead of Lucene, it will be whatever search as a service product that you want, as long as it is supported. And because it's an abstraction, if you're using Examine APIs, it means you can just continue to use the exact same Examine APIs that you want, and it will just work. Obviously, if you're casting to the underlying provider and using those specific features, that won't just work. It's not a drop-in replacement. So just be aware of that. But if you're just using Examine APIs as they are, just like Umbraco is, if you install this, it will just work. So all of the Examine back office search that currently happens, the Examine dashboard, all of that stuff, when you drop this in, everything will just work. But what is Azure Cognitive Search? This is a blurb I've taken from their website, and it's a lot of text to get through, but essentially, Azure Search is powered by Lucene, but they've added a whole bunch of smarts to it. So there's Microsoft Machine Learning and their AI implementation, and they've just added all of these features to their own Azure Search, which means you get a whole lot of really cool features in addition to Lucene.net. For example, out of the box, if you install ExaminX, automatically all of your Office docs, PDFs, and a ton of other files will automatically get indexed. So if your editors upload any media or upload files to your content section, if they're any of these document types, it will literally extract all the text from them, and then it will chuck it into your index, and then you can search on it just like you normally would. What's super cool, though, is Cognitive Search comes with some image analysis. So if your content editors upload any media as an image, there's all sorts of different features that Azure Cognitive Search can utilize. So for example, OCR will determine if there's any text in your image, and it will extract that text. And then we can put that back in the index to be searched on. Other visual features, you can configure all of these things individually. So you can just kind of enable them by config. But if you wanted to extract a description of the image, Azure Cognitive Search will literally generate a description of it and put it in your index, and then you can search on it. It can even go as far as detecting if there's celebrities or what locations they are, and it will extract that, put it into your index as text, and then you can search on it. There's even a ton more things. So these are called skill sets in Azure Search. You can even create your own, which is super powerful. You can create REST-based skill sets as well. So if you upload an image, it'll extract all that information, and it can send it to your own REST API if you wanted, and then you can actually use machine learning on that to then return some text, and that will go back into your index. So this is way beyond what Lucene can actually do, and all of these things can actually just be enabled in Azure Cognitive Search, and of course, because you're just using Examine to search on it, it will just return the results. So how does this all look in the grand scheme? Well, best practice is if you're using Azure App Service, you're probably going to be using blob storage. And for this setup, you have to use blob storage, because that's how Azure Cognitive Search works. Once your media goes into blob storage, behind the scenes, Cognitive Search will actually just go request those files that it hasn't analyzed yet. It'll analyze those files. It'll extract all the text, the descriptions, all of those things using all the skill sets, put all that information back into your index, and then with the Examine APIs, you're just using the normal Examine APIs, but with ExaminX, it's the glue that ties that back to Azure Search, and you can just query on any of that text and return it. So, problem solved, right? Now we've got one index, we've got stable load balancing, there's literally no overhead in scaling. You can scale out to 20 servers, and it's not going to touch your database at all, because your index is always online. You can use the exact same Examine APIs that you've always used, and it will just work. And plus, out of the box, if you're using Azure Cognitive Services, or even when we get to Elasticsearch, which offers different services, you get a whole bunch of extra features. And just like we mentioned before, you can actually still cast the abstraction to the implementation. So here's an example of casting the iIndex abstraction to the actual implementation in ExaminX, and now we get an Azure Search Index instance. And from there, if you wanted to use the Azure Search services directly and utilize any extra features, then yeah, you can just go for it. So this is just a quick wrap-up of some code, of how you might be able to save some code and some headaches. So remember, Lucene is 450,000 lines of code. There's a lot of API surface area that you would need to know. So let's have a look at spatial search. I've posted this on my GitHub. This is on Examine GitHub, and it's an example of spatial search with Lucene. So before, we've already casted to our Lucene searcher, and this is how you would do spatial search. I'm not going to go through this line by line or anything, but you can see that there's a lot of setup here, right? I don't even know what half this stuff means, but I've taken all these examples from the Java Lucene source code. If you ever want to do anything with Lucene specifically, that's your best place for documentation, because the documentation for like these low-level things are super sparse. But they've got tests for all of this, so that's your best place to look. But we're going to go set up a spatial search here, and then it keeps going. Now we're going to set up more of this spatial search, right? We're going to set up a bunch of arguments, and we're going to make a filter and a query, and then finally, we can use the Lucene index searcher to search on it, and it's going to return Lucene results for spatial search. But this is a lot of API service area to actually know and learn. What I didn't put here is what happens behind the scenes, because this isn't even enough to get this happening. You have to use the examine events to store geolocation information in a specific way. So there's actually more code involved to do this. So let's have a look at what's required to do this in Azure Cognitive Services, where you don't need to know Lucene. It's just one page. So we set up our search radius, our max results. We chuck in this OData string, and there's tons of documentation online for how to do that. And then we just use our casted index client that we showed before, and we get the results. Boom. It's the exact same thing, but you don't need to know anything, because Cognitive Services takes care of all that stuff behind the scenes. And with that, I think I'm on time. Yes. That was a quick rundown of the ins and outs of Umbraco, Examine, Lucene, and Azure App Services. I hope you learned something. Cheers.